So as we start now lesson 3.3, we have two learning goals again today. The first one being I can determine the independent and dependent variable of a function. You will use this every single math class from here on out. You need to be able to determine what is the independent variable and what is the dependent variable of a function. Okay? And then you have to be able to, they want to introduce you to writing an equation in function notation to represent a function. So we'll be covering both of those topics here today. So first of all, we're going to talk about like how can we write functions and what are all the things that we need to know about them. So an algebraic expression that defines a function, in other words, it tells how the function operates, we call that a function rule. Okay? So when we have an algebraic expression, which we know what an algebraic expression looks like, an algebraic expression does not have what? Expression. It does not have what? I can't hear you. An algebraic expression does not, well maybe, somehow, figure it out. An algebraic expression does not have, by the way, on the video tutorials, they don't torture you like this. An algebraic expression, an expression does not have, thank you, Natalie, an equal sign. Oh my goodness, that was way back in the beginning of the year we learned that. We had to retain that for a full, almost 3 months. Okay, an expression does not have an equal sign. So when we talk about the function rule, the algebraic expression that represents the function rule itself does not have an equal sign. Well, for it to be an algebraic expression, what does it have to have? There's one thing it has to have for sure to be an algebraic expression. Now the key term in that is algebraic. And the torture continues. Algebraic.
Did I tell you in the book?
Which probably did way back in the beginning somewhere when we learned this. But apparently we really didn't learn it. Lindsay? A variable. Thanks, Lindsay.
Wow.
Thank goodness for the corners back of the room here. Lindsay and Natalie. An algebraic expression, so it has to have a variable and it does not have an equal sign. It's a rule that says this is how the function is going to operate. When we talk about the input of a function, in other words, we put something into the rule, we call that the independent variable. So the input of the function, so when we put something into the function rule, that is our independent variable. I like to think of it like this. It's the controlling one. You know, when you're really, want to be independent of your parents, anybody want to be independent of their parents? You're like, you know what? I'm sick and tired of their rules. You just want to control your own life, right? You just, I got this. Yeah. So think of it that way. When you want to be independent, you want to be in control, don't you? You don't want somebody telling you what to do. You want to be the one saying what should be done. So independence, control, it's the input. It's what, you know what? Oftentimes you guys feel like you don't get enough input. You don't get to be independent enough. Okay, so tie all those things together to think about what does independent variable mean. And often, I want you to circle this, often our independent variable is represented by the x value. Sometimes they end up changing things up and they call it A, or they might call it M, or they might call it T, or, they just change it up every now and then. Typically, though, it is the X value in the function. Well, the output, the result that you get, so when you make that decision that you can stay out till midnight when your parents said, no, you need to be home at 10. When you stay, the output of the function, so when you decide, no, I'm going to stay out till midnight, the output, the result of that would be probably a grounding or take your cell phone away or, hold your allowance or who knows what. So there's always a result When something happens, there's a result of that. There's an output. Something, is dependent upon it. So the output of a function is the dependent variable. It depends on what was put in. And it is often the y. So if they use x in the function, they probably are going to use y for the dependent variable. If they use a, they are going to use maybe b or who knows. If they use t, they're going to use t and who knows what else. But typically, they use x for the independent variable and y for the dependent variable. And then a method of writing functions that is commonly used is function notation. Function notation. So we're kind of just covering what do each of these things kind of mean of our learning goals today. So when we write a function in function notation, the function rule, okay, so why don't you underline that? The function rule is set equal to this right here. Equal to that f parentheses x instead of y. So instead of setting it equal to the y, they set it equal to this f parentheses x, which is actually read as f of x. This is how we read f parentheses x. We don't say f parentheses x like I just did. We say f of x. And that actually is naming the function. So here's what it's saying. We have a function f, and our function's independent variable is x, and that rule on the other side is going to get the result, and me, f of x, I really represent y, the dependent variable. I represent the result. So the function is, when the independent variable x is plugged into the function rule, this is the result we get over here. Okay, so we'll be practicing some of that. Okay, anybody have any part of that you want some clarification on? Or more torture? I'll take that as a no. Writing an equation for a function. So here's our table of values. It's a relation. And why is that one a function? Why is that a set of ordered pairs there given in table form? Why is that a function? You've done 2 days of assignments on it. Come on.
Because the domain has only one range value.
Each domain value, not just the domain, the elite domain. Each domain value has exactly one range value, right? One is paired up with, this is not a hard question. One is paired up with, 2 is paired up with, 3 is paired up with, 6, 4 is paired up with,
7.
Oh my goodness, see how easy that was? Okay. So, what is the independent variable in that one? Which numbers are representing the independent variable?
The x.
The x. The 1, the 2, the 3, and the 4. Those are our inputs. Those are our inputs. And the outputs are the 4, 5, 6, and 7. Okay, the 4, 5, 6, and 7. So what we need to do is we need to figure out what function rule created those ordered pairs. So we need to figure out what happened to x that got us y. How can we get from x to y in that table? Add 3. Okay, so 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. And 4 plus 3 is 7. Huh. It works for all of them. It has to work all the way across the table. Not just the first time and the second time. And then all that, it must be the rule. It can change on you. You got to make sure you go all the way across the table. So we're going to write our function rule out first of all in words. If you add 3 to x, you get y. That's what we just did. We said we just went through the whole table. We added 3 to the x value, and the result was the y value. So then our equation would be just what we wrote there. Y, you get y when you add 3 to x. So, or we could have written it like this. Add 3 to x, you get y. Or we could have written it like this. Because order doesn't matter in addition, we could have written it as 3 or x plus 3 equals y. We have so many options. The y though, the output, the result is all by itself on one side. And the function rule, x plus 3 or 3 plus x, is on the other side. So the y is set equal to the function rule. When we have to write it in function notation, our f of x, because we have an x in this situation, it's the independent variable, our f of x has to replace the what? What did it say up above? What's the f of x going to replace? What is it the same as? The what? The y. So we're just going to take that y right there and we're going to replace it with the f of x. So f of x, the function, with x being the control variable, the independent variable, is x plus 3 or 3 plus x. Typically we'll see it written x plus 3. Typically they have the variable first, the variable term first, and the constant term following it. So f of x equals x plus 3. So when they ask you to write it in function notation, there's not a y in it. The y has been replaced by the function notation f of x. Okay, you go ahead and try number 2 to figure out what's going on in that one. We have this relation that, by the way, is that one a function? Because if it's not a function, it's going to be pretty hard to write a rule for it. So we've got to first determine, is it a function? Yeah. Each domain value has exactly one range value. Okay. Then you got to decide what's happening in that one. What can you do to x that will get you y? And feel free to talk to a table partner if you want. Figure this out.
See, I know what it is. You're adding by 0, 1, 2, 3, but I don't know how to write it down.
By the way, how many operations are there in math? How many operations are there?
What is that?
How many operations are there in math? 4. Huh. Adding, subtracting, multiplying,
Add 1, 2, 3, 4,
dividing.
5.
And can there be combinations of those? So you might have to think outside the box if you're just not adding something. You are, and you're still in the paper. Okay? Try harder than that. Yes, Monica,
I'm having a hard time here.
you are.
Yeah.
Darn, I hate to start your Thursday out like this.
Yeah, make me sad.
I know. Maybe we can help you out here in a bit. Anybody got this figured out? Monica doesn't want to be sad any longer. Please help her. Anybody figure out what we got to do? What the function rule is in words? Eddie?
Would it be if you added the first two domains, then you get the second range, and if you add the second and third domains, you get the range?
Okay. So if you add the first 2 domain values, you get the second order pair's range value, he says. If you add the next 2 domain values, you get the range value of the second one. How are we going to write that in algebraically? I think that is true. That is what's working. That is what's happening. But how would we write that? think we could clean that up, Annie, to make it a lot easier maybe to, Natalie?
I just put add 1 to x and add 2 to y, then you get your next coordinate pair.
Oh, but who gets to control the situation? Does Y get any say in this? No, only X does. Y is the result of what you do to X. Y is, it's no part of it. Y does not get to have anything to say about it. Only X does. Anybody else want to try? Okay, the hint. Multiply X by something. Benton?
The x times 2 minus 1 is equal to y.
Okay, so if you double multiply the X value by 2 and then subtract 1, you get the Y. You guys want to check it out? Let's see. So if you double 1 in the first one and you subtract 1, so 2 times 1 is, take away 1 is 1. 2 times 2 is 4, take away 1 is, oh, so far it's working. 2 times 3 is 6, take away 1 is 5. Huh. We're on a roll, we got 1 to go. 2 times 4 is, take away 1 is, Benton's got it. If you multiply, are you feeling better now, Monica? Multiply X by 2 and subtract 1, you get Y. So we're writing it out in words first. What happens if you multiply X by 2 and subtract 1? And by the way, in order of operations, would that take care of it? Do we multiply before we subtract? In order of operations, we do, right? Okay. So you multiply X by 2 and subtract 1, you get Y. Okay, go ahead and write the equation for that now. With your X and your Y involved in it, you know, how can we write that now algebraically? We wrote it in words. How can we now write that algebraically as an equation? Okay, volunteer. Abby Ben, you already gave us the function rule. Yes, Monica.
Y equals 2x minus 1.
It is. Y equals 2x, subtract 1. Now in function notation, how would that look? Say it to me. What would it look like? F of x, which we know is written like this, F of x equals 2x minus 1. Now you're going to be doing this in your homework. Yeah. Sometimes it's really nice, it's just adding and subtracting something, you're like, cool. And then there's other times you're going to be like, I cannot figure this out. You might have to do some multiplying, dividing, subtracting, adding. There's going to be a couple of things maybe going on sometimes, like in this one. Okay? So anybody have any questions before we move on? Okay, let's go to the back side then. Okay, being able to identify the independent and dependent variable in situations. A doctor needs to know your weight before determining the amount of medication. So when you go to the doctor, you get prescribed things every now and then, right? Antibiotics, something, whatever. Do they just give everybody, you know, if they see that you have strep throat and they say, okay, the last person with strep throat, I gave them amoxicillin, so I'm going to give you amoxicillin, and I'll just give you the same amount. Is that what they do? They don't, do they? What do they do? They have to figure out what? They got to figure out how fat you are, how skinny you are, or, you know, just right you are. And they got to figure out, in other words, they got to figure out, it says, a doctor needs to know your weight. They look at your chart and see how much did they weigh. Remember, they weigh you, right? Don't they weigh you when you go to the doctor? Even if you don't want them to? Sometimes they're like, ugh. Okay, so what is the independent variable in this situation? What is the controlling thing that, because of that, this is the result? Austin?
Weight.
Okay, so your weight is the independent variable. How much you weigh controls the situation. And then the dependent variable, the result is what?
Amount of medication.
The amount of medication. In this case, we don't know what either of them are being measured in, so we don't have to put that. We just have to identify what depends on what. So the amount of medication that you get prescribed depends upon how much you weigh. Skinny, fat, just right, doesn't matter. This is how they determine it. Okay, you figure out the next one. What would be the independent and what would be the dependent variable? And a company charges $10 per hour to jackhammer, to rent a jackhammer. They don't do it for you at $10 an hour. Wow, that'd be good. Just to rent their jackhammer. So what's the independent variable? What's the control factor in this? And what's the dependent variable, the result, because of the independent variables control? Now, we have a really hard time, I've discovered, describing x or whatever your variable is in an equation when you set up your own equation for inequality. So this is going to be, I'm going to be just as fussy on this. You have to know how to describe it properly. Okay, so who wants to offer up what they think the independent variable is in this situation? What's going to be in charge? Chase?
How many hours are you going to use it?
Yeah, how many hours you're going to rent it? Hours of rent. We'll call it renting. That makes more sense, it seems like. Hours of renting. So you decide, you know what? This is how many hours I want to rent it for. You get to control that, don't you? Okay, what don't you get to control? Other than, you get to control the hours, but Chase?
How much you're going to pay?
Yeah, how much you're going to have to pay? Well, we have to be more specific than that because we already know something about paying $10. So the total charge, wouldn't it be? Yeah, the total charge, how much you're going to have to pay. So total charge, we could call it. We can't just say how much you're going to have to pay because you know what? Pay what? To just step onto their property or just, get to hold the jackhammer or what's that about? Okay, so you're going to be doing some of that in your, some of the homework that is in your choices. Questions? Okay, now we're going to combine that with identifying the independent and dependent, and then putting an equation together that will represent the situation. So, notice what it says. Identify the independent and dependent variables. Write an equation in function. So let's maybe underline these directions because you guys tend not to read them. Write an equation in function notation. A math tutor charges $35 per hour. If you think that's expensive, no, it's really not. Believe it or not, you can add more. Okay, so what's the independent variable in this situation? What do you get to control? Number of hours. Okay, you get to control the number of hours. You know what? If you can only afford $35, then you are going to just hire that math tutor for an hour, aren't you? What's the dependent variable? Total charge. Yeah, how much is it going to cost you altogether? Well, if you can only afford 1 hour, your total charge is going to be $35, right? If you can, you're like, you got lots of money. The important thing is you learn the math. So you're like, okay, I got 4 hours free tonight. I'm going to hire this math tutor for 4 hours. How much is it going to cost you? How much? How much? $140. Okay, well, I just wasn't sure I was hearing it right. I thought I was hearing like $2,400. This is really an expensive math tutor. So how did you get $140? 35 times 4 or 70 plus 70. Yeah. So we need to write an equation that no matter how many hours we hire this math tutor for, the equation that we write will give us the result that we are looking for. So what equation could we write for this? And it's okay if you start it with y equals. You can always change it then to function notation. So let's just do that in fact. That's always, it's sometimes easier to start it with y because it makes more sense to us. y, the result, the total charge. We're going to get it by doing what? Let's see, what's the function rule? Take the number of hours times 35. Yeah. What would that look like then? 35x. The good news is they don't have this one-time fee just to show up and be your buddy. They just charge you $35 per hour, right? And then, so then, written in function notation, what would that look like? F of x equals 35x. Yeah. F of x. So here's our final equation in function notation, and then we also describe our independent and dependent variable. Okay, go ahead and do number 4. Tail of the independent variable is? The month.
How many months?
Okay, how many months? Okay, so I'm gonna put number of months. We can't just put month or months. That's not gonna cut it. Month. Okay, so January. February. Okay. What's the dependent variable? Easton?
Total cost.
Total cost. How much is it gonna cost you all together? And by the way, this total cost, do we know what it'll be measured in? In what? Dollars. Okay, so sometimes it's kind of nice to do that. So total cost in dollars. Okay, and then the equation for this one. Well, I'll let somebody volunteer for the equation. Lindsay?
Y equals 100 plus 40x.
Okay, written not in function notation. Is Lindsay right? You agree with her? Y equals 100 plus 40x. What's another way we could write the function rule? Do we have to write it 100 plus 40x? Macy?
Do y equals 40x plus 100.
Yeah, that would work also, wouldn't it? 40x plus 100. What we have to make sure is we have that plus 100 because that's the one time, that's the membership fee, right? And then we have to add to that how much it's going to cost us according to how many months we do it. And so this would be our equation. Now let's write it in function notation. Our y gets replaced with f of x. And typically, I'm going to write it the way we would typically see it. Whoopsie, I always run out of room because I just write so big. This is a 100 here, 40x plus 100. Okay. Okay. So you'll be doing some of this stuff. Identifying the independent and dependent variable along with being able to write an equation and being able to write that equation also in function notation. Okay, now I want you to answer this last question for me. Does f of x represent domain or range? Why? It's replacing one, that's right. So let's circle range and say it replaces, it's the same as y. Okay. So our f of x values, if we see it in a table, instead of them putting y values, they put f of x values, we're like, oh yeah, bingo, that's y. That's what they mean. They're giving me the range values. Sometimes they just don't do them as y's, they call them f of x's instead. Okay? Okay, anybody have anything we should talk about before we say, amen, I get points for this? You want to say yay? Okay.